The topic of today's lecture is differentiation or differentiation of a function. In this lecture, we will cover these topics. First is definition of differentiation, examples, derivative of some standard functions, sum rule, product rule, and quotient rule. So first of all, the definition of differentiation. The differentiation of a function or a derivative of a function at a point x is equal to a can be calculated by this limit. Here at we have to find the derivative at a, so we'll evaluate the limit h tends to 0 fa plus h minus fa by h. In place of a, if it is b, then we'll write limit h tends to 0 fb plus h minus fb by h. So according to the point, whatever point is there, we'll write the definition accordingly. Now let us see one example. Here the function is fx is equal to x square and we have to find the derivative f dash 1, that is derivative of f at 1. So we'll use the definition because we have to find this value by first principle or by using definition. So f dash 1 will write this is a limit h tends to 0 f1 plus h minus f1 upon h. Now fx is x square, so f1 plus h become 1 plus h square and the value of f1 is 1 square by h. And when we'll simplify this become 1 plus h square plus 2h minus 1. This 1 and 1 will get cancelled and we're left with h square plus 2h by h. Now this h and h will get cancelled and limit h tends to 0, h plus 2 is equal to 2. So this will be the answer in this case. Now let us see one more example. Here the fx is x square plus 2x plus 4 and we have to find the derivative at 0. So first of all we'll find the value f0, that will be 4, that we'll use here later on. Now we'll apply the definition of limit. We have to find the derivative at 0. So we'll write limit h tends to 0 f0 plus h minus f0 by h. And fx is given by x square plus 2x plus h. So we'll write in place of x, we'll write 0 plus h square plus 2 times 0 plus h minus f0's value is that we have calculated, that is a 4. And now this 4 and this minus 4, because of this minus, this become minus 4, so this 2 will get cancelled and we're left with h square plus 2h by h. And finally this h and h will get cancelled, numerator and denominator, and we're left with limit h tends to 0, h plus 2, and its value is 2. So by this way, using definition, we can calculate the derivative very easily. Now let us see some standard formulas of differentiation. The derivative of x to the power n become n times x to the power n minus 1. So let us understand what type of this formula is here. If the derivative of x to the power n, then n comes down and the power is reduced by 1. So power becomes n minus 1. Using this, we find the derivative of x is simply, it is 1, it's not x, it is 1. And the derivative of constant is 0. Whenever some constant is multiplied with ax to the power n, it becomes a times derivative of x to the power n, and this can be calculated by this formula. Then derivative of e to the power x is e to the power x, derivative of log x is 1 upon x, and there are some trigonometric formulas of differentiation. The derivative of cos x is minus sin x, derivative of sin x is cos x, derivative of cot x is minus cos x, cos x square x, and all these are formula that you will have to memorize. Now let us see some examples here. The sum rule is there. Whenever we have to find the derivative of sum of two functions, and that can be calculated as a derivative of first function and the derivative of second function. So simply Here we will have to find the derivative of these two functions separately and add. For example, derivative of x square plus 3x. So x square is first function, that is fx. Derivative of 3x is gx. So derivative of first function will write d by dx of x square. Derivative of second function will write d by dx of 3x. It becomes 2x plus 3. So this will be the answer. In this case also, e to the power x is fx, that is first function, x cube is second function. So derivative of first function will write d by dx of e to the power x, and derivative of second will write d by dx of x cube, and derivative of e to the power x is e to the power x, and derivative of x cube is 3x square. So like this way we can calculate all these derivatives. For example, x to the power 5, derivative of this is 5x to the power 4, and derivative of 4x, 4 come downs, it become 4 into 4 16, and power is reduced by 1, so it powers become 3. Now in this case, in this final example, here the power is x to the power minus 2 and x to the power minus 3. So derivative of first function, derivative of second function, minus 2 comes down and the power is reduced by 1, so it is minus 3. Here also power is comes down, minus 3, and power is reduced by 1, so it is minus 4. Now let us see whenever we have to find the derivative of product of two functions. So here the formula is the first function remain as it is, and we find the derivative of second function. Then we write plus, and the derivative of first function and second function remains as it is. So let us apply this formula over here. Here this x square is fx or first function. This x cube is second function. So we write x square derivative of second function plus derivative of first function and second function as it is. So x square remains x square, derivative of x cube. So 3 comes down and power reduced by 1. So it is x square plus derivative of x square 2 comes down. So it is 2x and x cube as it is. When we'll finally calculate this, it gives us as answer 5x to the power 4. Similarly, in this case, the first function x square is as it is, derivative of second e to the power x plus derivative of first function x square d by dx of x square and ex as it is, x square as it is, derivative of e to the power x is e to the power x, derivative of x square is 2x and ex as it is. So this is the final answer. Here also, this x is first function, sin x is second function. Here x cube is first function, cos x is second function. Now let us see the quotient rule. It gives whenever we are having that we have to find the derivative of fx by gx, the function of this type. So what we'll do, we will first of all do the square of gx, that is written in the denominator. We'll write gx as it is, then derivative of first function, derivative of function f minus f as it is, and derivative of the function g. Let us understand this by an example. This is very easy example. Here it is x square by x plus 1. So first of all, x plus 1 whole square, x plus 1 as it is, derivative of x square minus x square as it is, and derivative of x plus 1. So it becomes x plus 1 as it is, derivative of x square is 2x, x square as it is, and derivative of x plus 1 is 1. So finally, when we'll calculate, we get this answer. Similarly, in all these questions, we can apply this rule. For example, here we did x plus 1 square. Now x plus 1 as it is, derivative of x is 1, then x as it is, and derivative of x plus 1 is 1. So finally we get this answer. Here also we did the x square, then x as it is, derivative of e to the power x is e to the power x, e to minus e to the power x as it is, and derivative of x is 1. So finally we got this answer. So using this product rule, we can find the derivative of the function whenever they are given in this format or in this form. Now you can try this exercise here. We have to find the derivative of x cube is 3x square, derivative of 5x is 5. Here derivative of ex is e to the ex, and x to the power 4 is 4x cube. By this way you can find these values very easily. Then you can try this as a product rule. Here the product is given, so you can try. These are very easy. And the examples of quotient rule, here also this is your first two fx, this is your gx. In this case sin x is fx, x plus 1 is gx. So applying this formula as explained in the example, you can find the values very easily. The PDF of this lecture can be found in the link which is given in the description. I hope you understood all the examples. Thank you very much.